In this lesson, you and I will begin the process of architecting a solution for Acme. We know the high-level goals. We've begun to formulate a high-level design in our minds, or at least we've considered how the goals of the project will impact our architectural decisions, and we've decided that we're going to start with the domain layer. Now, many details will need to be fleshed out over the next few weeks and months while we're on this project, but in order to gain some clarity, we're going to start diving into the details of the system by attacking a small sliver of the overall functionality required by the system. So in the Application Architecture Fundamentals series, we called that an architectural spike. The architectural spike serves several purposes for us. At this stage in the project, it helps us to gain some clarity as to what responsibilities to delegate to each of the layers. We'll begin to use it to identify the key classes that comprise our domain layer. And perhaps most importantly, it'll help us identify issues that we need to solve or that we need more information about. Admittedly, it feels a little bit early to start writing code, but my goal is not necessarily to begin writing production code this early in the process, but rather, I think what it helps to do is drive that process forward. When we realize that we don't have the information that we need, we'll have to stop, find that information, then push forward. So our work here is to drive forward and to find all the roadblocks that might pop up and face them sooner rather than later. Okay? So later on, the architectural spike will help the rest of the development team see what design decisions we actually made. In other words, it'll help them see the manner in which the layers and objects collaborate with one another to perform a task. They'll see examples of naming conventions that we've chosen. They'll be able to see examples of the technologies that we've chosen, and not just the technologies that we've used for the presentation and the persistent layers, but also logging technologies and the isolation framework, the unit test framework that we've chosen, and so on. All right. So the first thing that we're going to need prior to building the architectural spike is some requirements. And there are entire careers built around defining formal requirements. So there's no easy way that I can do that topic justice in this series. It's definitely not my area of expertise, so you'd be better off finding some training specifically on that elsewhere. However, in my experience, anecdotally, I've seen one of several scenarios. First, nobody's taken the time to even write down any of the requirements for the new system. It's solely in the heads of the stakeholders or key users of the system. And then secondly, another scenario that I've seen frequently is that some effort has been taken to define the requirements, but they're usually woefully inadequate. They address things that that are not really business process related. They're like, we need a report in this format. We need to push a button and this to appear on the screen. It's like, no. Let's not worry about that. Let's just abstract all that away. Let's talk about what is the business problem. We'll worry about those sorts of inputs and outputs a little bit later on, right? But they're thinking very concretely about the system and maybe not abstractly about the business process. So they have requirements. They're just not in a format that we can do anything with, frankly. And then the third scenario that you come across sometimes is that a lot of effort has gone into creating the requirements to the point where it might be overwhelming. They put a stack of binders on your desk this tall, and they say, here's the requirements, hundreds of pages of documents and diagrams and things of that nature, and you're like, oh my goodness, where do I start with all this, right? But in my experience, honestly, I've seen typically there are fewer requirements than more requirements. It'd actually be nice to get more requirements occasionally. So to keep things simple in this example, we're going to pretend that Acme hasn't spent a whole lot of time codifying the requirements in a formal nature. But regardless of whether you had a great set of requirements or no formal requirements at all, we're going to want to translate the requirements into a format that we as developers can take advantage of. In the past, use cases were a popular format for developer-centric requirements. It was part of the UML specification. More recently, a lighter weight style, an agile style of developer-centric requirements that has emerged called user stories. I described them earlier as bite-sized descriptions of a task that the system has to perform. We're going to use them for planning and estimating, but also to help drive the discovery process and learn more about the specifics of the system at the time when we need those specifics. But once I have some initial user stories defined, my goal is then to analyze the user stories and begin the process of identifying candidate classes, or rather those key classes that represent major concepts or entities in the solution that will collaborate with one another to enable business processes. At that point, we're going to be moving away from a high-level analysis to a more low-level detailed analysis. So let's pretend for now that we work with the stakeholders to capture a few very basic user stories. We can add, and we will add, many more throughout the course of this project as new details emerge about the proposed system. But let's look at the first, most basic user story that we can possibly come up with. So here it is. As a field service technician, I want to locate the customer service contract in the system so I can create a new order for the customer. All right. So a user story is just a simple description of a scenario for the purpose of scoping out the work that's required to build the functionality to support the given scenario. It's the basis for further conversation and requirements gathering. Based on this most basic explanation, the project manager would ask the developers how long that they think it would take to build this functionality into the system. A user story should be in the form of, as a role, as a user, as a technician, as whatever the case might be, I want to do something meaningful in the system so that this expected outcome happens, okay? So as you'll learn in the series about Agile Development and Visual Studio Team Services, which will be a series that will create, it'll talk about user stories and how they're combined together to determine what can and can't be accomplished during a given iteration. They also help the team understand the intent of the system and ask better questions about the details of the system. They're short. In fact, they should be small enough to fit on an index card, right? That keeps their level of detail intentionally at a high level. Developers are encouraged then to make assumptions about the scenario based on what they already know about the client, the existing system, their experience as software developers, and so on. Ideally, more experienced developers will recognize those areas that should be easy and those areas that might represent a risk, where more information is required before they can provide an estimate on the time required to complete that user story in code. Mainly, user stories are used as a project estimating and planning tool. The project manager will ask the developers to provide their best estimates on how long it would take to build the functionality described in the user story. Now, if the user story is unclear, the developers can discuss assumptions and raise questions to help get more clarity on the matter. This would prompt the team to work with the customer to get more detailed information about the scenario. They might get so much information that it would require more user stories added on to the deck, so to speak, to those that are being considered for inclusion within this or some other iteration. Again, more about that in a whole other series. Let's do this for the moment. Let's fast forward in time and let's assume for a moment that you and I are not architects anymore. I'll come back to that whole notion just a little bit. Let's talk about this project planning and estimating piece just a little bit. For now, let's pretend that we're just two developers on the team who will be working on this project, and we're past the architectural spike phase of the project. We're fully, in the middle of developing the project at this point. And so we're sitting in a room with the project manager. She has scheduled this time to play a round of planning poker. And so each developer is given a deck of cards, and they have numbers on them, like 0 and 1/2. 1, 2, 3, 5, 8, 13, 20, 40, 100, which would represent a really long time. A question mark, which would mean I have no idea. And then there's another card that has a coffee cup on there that says, hey, I need a break. Okay, and if enough people turn that over, I guess it's time to take a break. So the project manager reads a user story. All the developers keep their cards close and they don't show what they have in their hand. And then after she reads the user story, she asks everybody to pick a card that represents their estimate, whether it's half, 1 day, 2 days, 3 days, 5 days, or the like. And then once we've all made our choices, we then show our choice, our card, at the very same moment. Now, the developer who picks the lowest estimate and the developer that picks the highest estimate is granted the soapbox. They have the opportunity to explain their rationale for their decisions. Now, even though we fast forwarded in time for this little tiny scenario I'm talking about here, let's suppose that we've already got some of the functionality for the application finished, and yet there's still a lot that's unknown. However, in this case, in this particular user story that the project manager has read to us, it just so happens that I personally have had some experience with the project. I've had experience with the client. I know about the functionality that's described by the user story. I've already heard the customer talk about this. So I make some broad assumptions about those parts that I both understand and the parts that I don't fully understand. And so I throw out a number. I say it'll take 4 days. Well, this would allow me to create the unit tests and the production code as well. I feel pretty confident that that's enough time to flesh out those parts I don't understand. It doesn't sound like that difficult of a user story on the surface. And so it gives me a little bit of leeway to tackle those parts I don't yet understand about the system. We're still early in the development process, and I expect that this estimate will be off the mark, but it's a start. And once I know more and the rest of the team knows more about the problem domain and the state of the code, we can give better estimates as time goes on. Now, it just so happens in this little scenario that I'm describing, my estimate of 4 days is on the upper end of all estimates. Most developers either pick 1 or 2 days. Well, that's fine. I'm now given the soapbox. In other words, I have an opportunity to explain my rationale for the high-end estimate. I explained how it was implemented in the old system. I give a few examples of the issues and the unknowns that I have in my mind. And while there's some discussion about that, the other developers tend to agree that this particular user story may uncover details that we're not already aware of. The project manager takes down a few notes and she continues on, and we continue this exercise until we've gone through all the user stories. And so we continue to play this game for all the other user stories, and now the project manager has a pretty good feel for the amount of work ahead, or at least she has a rough estimate. Now we're going to talk about the project manager's use of these estimates when we talk in more detail about agile planning, estimating, and development with Visual Studio Team services, so I don't want to talk about that right now. But for now, let's switch back. I want to stay focused on this from an architectural perspective. So we're switching gears back. We're going back in time now, and we're tackling the architectural spike. You and I now reclaim the roles of architect on the project, and we're going to pretend the planning poker never happened, okay? Now, before we get the rest of the development team involved, you and I need to make some key architectural decisions around the composition of the layers, the major classes that will be delegated responsibilities of the system, and so on. So our aim as architects is to pick 1 or 2 of the most fundamental user stories off the deck and tackle them in an effort to create an architectural spike through the system. Once we create our architectural spike, we can provide better estimates, we can decide on conventions, we get the initial project set up and ready for the other developers to join us. We identify new questions and issues that need to be resolved, and most importantly, we provide a good template, a good starting point for the other team members. We can say, here, take a look, here's the interaction between the layers. You've been assigned this user story, so you can follow the pattern. Here, look at this code. Do it like I did this over here, right? User stories start out as very high-level descriptions of the functionality that we need to add to the system. However, as we begin to tackle that functionality and encode it into the system, we're going to need to discover more details and flesh out the user story that we're currently working on. This requires that the developer who will write the code base, who's been assigned this user story, has access to a client liaison, all right, the customer, or perhaps stakeholders or end users or anybody else who might have more details about this user story. Now, if there are too many details to complete in the current iteration, perhaps that will spawn new user stories that can be added onto the stack of user stories and tackled in future iterations of the project. So let's pretend that through conversations with the client liaison, through the stakeholders and so forth, we learn more about this user story. As a field service technician, I would probably already know the contract numbers. we have those stored in a customer relationship management tool, and part of the dispatcher's request will be an email with all the important details. So I am a field service rep. I get an email from the dispatcher who says there's a problem at this manufacturing company. Here, you need to go there and check it out. And so it gives me all the details in an email that's generated from our software system that manages the customer customer relationship, the contracts, and things of that nature. So the first step would probably be for me as the end user to copy the contract ID from that email into the new system that we're about to build to find the customer services contract and to kick off the ordering process. And then there's a series of checks that would need to happen on the contract. Is it valid? If not, then I would need to notify the account manager that the contract is expired. Ideally, that should never happen, but the customer may have been dragging their feet on renewing the contract, so this will definitely be the impetus to drive the contract renewal process forward. So for this first user story, we're going to make sure that the contract expiration date is in the future. If not, the field service agent is not authorized to create an order on behalf of this customer, and it becomes now an account manager issue. Now, assuming that the contract is not expired, an order will be created at the moment when we search for the contract and we decide to create a new order, and that new order will have a status of new. All right. As a field service technician, I'm going to type in a part number next, and I'm going to click on a button to search for that part in our system. Now, in different user stories, perhaps we'll be able to look up the machines that are owned by the customer to more easily identify the exact part number that's required. But for now, we're just going to have the field service technician type in that part number. It's encoded in a barcode on each part in the machines, in the CNC machines. So it should be relatively easy for the field service technician to find and type that number in manually. The system will return a list of those parts and what region they're located in. Again, another user story perhaps would detail how they should be sorted by geolocation in relation to the customer. Also, in a different user story, the field service technician should be able to see the nearby customers that also have this part in their personal inventories, so that I, as a field service technician, can get in my car, drive over to that factory, grab the part out of their inventory, and then take it back to the customer that needs it for this specific problem. So to create order items, I'm first going to select a replacement part from a given region and then enter a quantity. As I add items to the order, I want to see a running subtotal. I want to be able to easily review the items that have already been added to the order. Once finished adding items to the order, I want to set the status of the order to open and provide the customer with an order confirmation number. All right, so per our agreement in the previous lesson, you and I are going to be allowing the domain layer to drive the development of this application that I just described, and all these little business rules and all the classes that are going to need to collaborate in order to pull this off. This will allow us to focus on the most important parts first, getting the business rules around the ordering process correct. And we can worry about the user interface and the database access code a little bit later. But for now, getting the domain right is the first priority because it's the model of the business. So when I think of the domain, I think of the major classes and their interactions that are required to accomplish the user story as I understand it right now. So let me get you involved at this moment. We're just about at the end of this lesson, so answer the following questions. I have 3 questions for you, or actually I think there'll be more like you'll need to draw some diagrams. Based on your current understanding of the problem domain, I want you to create a high-level architectural diagram for a web deployment scenario. So we're going to map the layers in our application to physical architecture, or in other words, how we distribute the different layers onto physically different systems. And what I want you to do is just kind of like you see this example on screen. Use big boxes. A big outer box to indicate the physical tier where you want your layers to reside, and then use smaller boxes on the inside to represent the software layers. And so again, these bigger outer boxes indicate a physical tier, and by that I mean either a single machine or a farm of machines. And then the boxes that you draw inside of that represent the various conceptual layers of our architecture. For the most part, I'm talking about the layers that we learned about in the Application Architecture Fundamental series and where they'll ultimately be deployed to in our system. And I want to remind you, don't forget the auditing requirement as detailed in the previous lessons as well. We didn't talk about it here so much, but we know we need that to be a piece of our architecture. So at a conceptual high level, start to figure out what that would look like. And then what I want you to do is create a second diagram, and it's going to be another high-level architectural diagram for a native device scenario. So this will look a lot like the first diagram, but here's a hint. The presentation layer will look different, and at the very least you want to add another layer to enable many native devices, phones, tablets, Windows Store apps, and so forth, to access our domain layer. So how are you going to accomplish that? Moving on to the domain layer, the third thing I want you to do is diagram the major classes that you would envision being a part of our solution. Can you draw a simple UML class diagram that shows the classes and maybe some of the properties that you're going to create and the relationships between those classes? Now, honestly, it doesn't matter if you get these wrong. I'm not even sure that there's, at this point, that there's a wrong answer. Just look over both the user story as well as the additional information that I've captured from Acme's Client Liaison, and let's start identifying some of the candidate classes, attributes, and their relationships. And we'll see you in the next lesson. Thank you.